Welcome back to Abra Knowledge channel. Today we are going to discuss process capability for discrete data, or you can also call it as attribute data. And you will be wondering that when you say a process capability, the first thing may come in your mind that is all about the variable data, right? CP, CPK, process capability ratio, and process capability index. So often you might have heard this one. But let me tell you that process capability for discrete data, the same thing what you do in a control chart, the same thing you can achieve in the process capability for discrete data. Not only that, you can achieve more. Let me explain more in detail. And we are going to do binomial distribution, since we are talking about defective data. Just to be very clear, defective data is data when you have pass or fail. The kind of data you have a binary data, pass, fail, and reject, and good, and go, set, and all that example do attribute to binomial distribution, that we call it as a discrete data, right? And then we're going to compare P chart quickly, very quickly. We're going to compare the P chart, and we're going to do it process capability, and we're going to do it in Minitab. And two example I have taken, and this example, the one of the examples directly coming from Minitab. All you need to do is, when you have a Minitab, you don't need to be worried about it. You, all you have to do is you have to go to Minitab, file, open worksheet, look in Minitab sample data folder, and you will find defective records. And then this is already there. And I have also have an orbital example. That means these are the two columns. We're going to do the P chart, as well as the we're going to do the same thing in the Minitab also as well, and we are going to do it process capability and P chart as well. So let me take this as an first example. I have copied the data, and by the way, I have already have a data in this one, and all you have to do is you have to do go to the Minitab and go to file, open worksheet, and then you will find that look in data sample, look in Minitab sample data folder. Have a click it, and you can just click, because there are so many examples, though so many files are there within the Minitab, and you can just type defective, right? You will find defective records and open up. Okay, now it is being there. And now I will quickly do P chart. Why I'm saying P chart? Because it's defective. If it is defective, you have two choice. One, you can do a P chart or NP chart, or you can do, if it is C chart and U chart, you have to have a defect data, right? C chart and U chart. So it's very clear that we can use P chart. The same P chart, very quickly I will do the same thing. I'll come back and do it process capability also as well, right? Go to stat and go to control chart and attribute chart, because it's attribute one, and a P chart. P chart monitor the proportion of defective item used when the each item is classified into one or two categories, one or two categories only, like pass fail. In this case, defective against how much records, such as pass fail and all that. Okay, I click, and then what is that defective I have divided by total records I have, right? And I can just run all these tests, perform all the tests, and I'll give okay. I'll give okay. Very quickly, it says that I have a very less than 1%, not even 1%, very less than 1% records of one which I have a defective record, but there are outlier and all that. That further we will discuss. The same thing, much more than that, we can achieve through something called process capability. What I will do, I'll go to stat, and the same data, I'll use the same data, and I will go to stat and process capability, I mean quality tools. In the quality tools, I have something called process capability, and I'm going to use a binomial. See, straight away it says we can use it, because only for variable data you have to check the normality and all that. So normality doesn't exist. So determine whether the percentage of defective item meets the customer requirement. Use when each item is classified into one or two categories, such as pass or fail. The same tiny definition is given. And this is a defective. Constant sample we have? No, we have a variable sample. And I'm going to take like, so variable sample, this is total records. And historical p value I don't have. Target I will keep it like 0.01 percentage. Let's say I have to have a 1 percentage, right? And let's give okay. And okay, now almost similar fashion you will find there are how many, 7 outlier you have. Outlier on the upper side, it says 0.09. Let me tell in the percentage also as well, so that it will be easy for you. I'll copy this one and I'll paste it here, and all you have to do is just click this percentage, you will find it. That means to be precise, it is 0.9 percentage you have a defective. Let me elaborate. Yeah, 0.9 or 0.93 percentage you have a defective, right? Whereas our goal is 1 percentage, right? 1 percentage we can have. Let's say I will tighten up the percentage to 0.05. Only 0.5 percentage we should have. That means we should have, let's say, okay, we'll go back, and what I will do, control E I will give, and instead of that I will reduce by half, 0.05. That means only 0.5 percentage is a defective, right? I'm just keeping that in mind, that point target I am keeping like 0.005. In other word, 0.5 percentage I'm going to keep it as a target, right? 0.5 percentage. That means the yield I should have, the pass out I should have, like 1 minus this percentage, right? So 99.5% should be, all the record should be correct, right? Okay, go back to this example. 0.05 I'm gonna give okay. So you will find every information, the information, let me now compare. So this is the P chart, maybe not the P chart, we'll take the P chart also as well. Start quality control chart and attribute chart, P chart, and I'm gonna give okay, and I will keep both the windows side by side. So this is the P chart. This is the binomial process capability. You see that process capability gives more information. Why I said that? So you see that there are the same thing it is here, like the 0.0093, and then the UCL can go up to 1.4 percentage, and then it can go 0.3 to 1.4 percentage, and then 0.9 percentage we have as a defective. Okay, what is very very interesting is this information. Let me elaborate now. I will just minimize this. Let me elaborate more in this. What are the other things you have? First, cumulative percentage. This is very very interesting. So you have a target here. This is your target, right? I mean LCL, and then this is your middle value, and then this is your upper one. So that means it is almost here is fine, but the starting of the batch is having more and more. So up to 1 percentage also we have, and then they started coming down and so on, right? So this is the way, summary stat. Defective 0.93 percentage we have. This is percentage actually, right? So percentage 0.93, less than 1 percentage. Okay, not as a 93 percentage. This is just 0.93, less than 1 percentage. Okay, lower it can go 0.89, that's what it says, and upper it can go up to point with a confidence interval of 0.97, that is closer to 1 percentage, and the target we kept it as 1 here. Let me just take it to 1 percentage. Let me just check it to half percentage. Let's say half percentage. Maybe I will do it one more. I will reduce that target to half percentage. Let's see how it goes. Okay, quality tools. Yeah. So, and then you have a capability analysis, and then you have a binomial, and then 0.05. Let me take this one. This will be the better one. So you have here 0.93 and 0.89 is a lower one, upper one, and then target 8.01. I think this is rounding off. Okay, let me double check. Yeah, it is a rounded off value. So zero point 0.1. That means 0.5 we set it up this one, and ppm. This is the ppm, and z value is 2.3 sigma. Right, easily you can calculate the z value, because the same thing if you do it in control chart is a very very long step you have to follow. That also I will do it, but you have to follow a long step. right? A defective proportion, this is also very interesting. If we have like 1,000 samples, so our defect will be here. If we, the more we increase the, the sample and the scatter, I think the defective is coming down, right? That's a good news. If you have a low sample, more error is there, and then we can also get to have that, like a it's not a scatter diagram. A scatter diagram requires a variable, but it's not a scatter diagram, but you will get the one. And then you will also will get the histogram also as well, like what's not the bell curve, because this is not a variable data, just know how much frequency of this one. Mostly the data 0.9 percentage value we have, less than 1%, and less than 1 how much we have. So all this you can get to our target is here, but we are here, so easily we can get to. Now what I will do, I'll give control E, and I'll go to test, right? I'll perform all the tests, like what, how we did that in the control chart. Like this, all 4 tests we can perform. It does say that only the condition number 1 is failing. That's okay. And let me control E, I will do it. And let me also do the other option. In the options, I will give a title like records defectives process capability. Process capability, and then okay. And then you can also find like storage. This is very important, and you can give a target. The target will get displayed. Process sigma and ppm in defective you can get to know. Percentage you can get to know. Lower percentage, what, how much the maximum sigma value. Process z stand for sigma value, or capability. Or you can also say that process, how much process z bench or process z are same, and effective and average how much it is there, and I'll give okay. I'll give okay. So what is very interesting, it you will also find the value here, like ppm also you have found here. If you go back to your data set, you have all this here. Like this is in percentage, I mean this is in number, this is in percentage, like so 0.92 percentage, less than 1. So target is 0.05 percentage, and this is the ppm, this is the sigma value, this is the lower one, this is the higher one. Everything we got to know. The same thing, if you happen to do it in many excel, it's a very very tedious job, right? And let me quickly do that just for the benefit of one. What I will do, I will just hide everything, and I'll hide everything, and I'll put like individual percentage, defective percentage, I'll put it. And then I'll put like total defectives and total records. And what, because the denominator are different, so I should not do the average directly. So cumulative or P bar, we can say P bar or average. And that average, what I will do, and I can convert into ppm, I can convert into uh, sigma value and everything, right? So let's see. So very simple, total defective divided by this, and this is the percentage you got. And so it's not fair to do it an average 0.009, this is not a right one. So what you have to do, you have to add everything. This is defect, and total defect is 2000 records. Are there a problem? Total records, how much we have, and p value is this divided by this. You got the p value also as well. This exactly the same 9296, right? The same value we got it here. You can check it here. So it is rounded off again, right? Almost the same value we got it here. Maybe I can just make it small. You see here, 00930, exactly the same thing. Let's say ppm. Ppm is very simple formula, and if you wanted to check more about, we wanted to get to know more about ppm, dpmo, dpu, everything, you can check out my previous video. But however, I'll do it quickly here. So ppm is equal to total defect 2 into 10 to the power of 6. I'll just take 1 to the power of 6, 10 to the power of 6 divided by 10 to the power of 6, or 6 zeros you can add, 1, 2, 3, 4, 5, 6, 1 million divided by total records. So this is the value we got it, right? 9296. Exactly this matching. Perfect. And furthermore, what I'll get rid of the decimal, and sigma value equal to n and inversely proportionate 1 minus this ppm value divided by 1 the power of 6, sorry, 1 the power of, okay, maybe let me do it one more time, equal to n inversely proportionate 1 minus ppm value divided by 1 the power of 6 plus shift can happen 1 point up to 1.5. So 3 point, precisely 3.85. Exactly the same value we got in the Minitab also as well, right? So the process capability, this is lower and higher we have. And let's see, this is, we are talking about, okay, this is only we are talking about this is, there is no shift because this is not a variable data, sorry, correction, it is not a variable, it is a discrete data. So 1.5 does not exist. So that means flat 2.35, you will take it. So 2.35 exactly, it is matching the same. Exactly 100% correct, right? So like this you can do, but you can imagine that the same step you can do using Minitab in less than 1 minute. Let me do very fast. Start control, I mean, you can go to quality tools and capability analysis, binomial, click it, and you have feed in defective total records, and we kept the target as 0.05, and you're given set, that's all, finish everything, it is given this one. This is very, very useful. Let's go back to the second example. Since we have created one more time, it has come. What I will do, I will give new sheet and I will keep it here. I'll go back to this. Total calls considered as a defective, right? Unanswered call will be considered as a defective, right? Copy this value and paste it here. Let's do P chart quickly and then let's do this chart, like process capability also as well. Start, control chart, and a P chart, right? And in the P chart, I'll give F3 so that I can start from the beginning. Total unanswered divided by total calls. And I'm going to test all the conditions. Fine. Because discrete data does contain only 4 control limits. I mean, control checks. Okay. Now 7%, right? 7.8% we have, only one outlier we have. Okay. And the same thing, what I will do, I will do it in the process capability, quality tools, and then you have a binomial distributions. I'll give F3 so that all value will go off. So unanswered call, and I don't have a constant sample because the pulse I can see. Total calls I can put it historical. Let's keep the target as 0.5. Example, right? 0.5. Okay. Now you can see that, the same thing. Maybe I will just minimize a bit. Exactly the same thing. So here 0.7823, exactly the same, but we have additional informations here, right? So in the beginning, if the sample size is here, we have more issues are here as the sample size increases and the probability of defectives are getting reduced. That's a good news, right? And then again, it also says the same thing. If the sample is 500 around, we go up to 12% defective, and if the 700, the error is between 5 to maximum 8% or 8.4 to be precise, right? And then mostly the issues are happening here. This is not a bell curve because bell curve is only for variable data, and you have here, and then you also have defective 7.8% and process sigma is 1.4, right? And let's do the same thing in Excel also as well. Let's prove that whether the same value we are getting it, right? So I will hide everything. I'll do from the beginning. Okay. What I will do, I will just find out directly cumulative total calls, total defective I'll consider because it's a unanswered call will be taken as a defective, and then P value or average defective, and then ppm I will take, Okay, ppm I will take, and then sigma value I will take. So how much sigma value we have got here? So you can see here the sigma value we got, and we can just opt for it. So once again, Control E, and I can go to this, perform all the tests. That's okay, and options. Okay, and storage, average value, defective, process capability, both the one lower and upper and overall. Okay, you have here. So how much the defect process capability you're getting it? Process Z or sigma value, both are same. Sigma value 1.4 we are getting. Let's see how it goes. Okay. And what you have to do, you have to keep it like total calls. I'm gonna sum this up, total calls, and then sum this one, and then you have a p bar value, this divided by this, and then ppm. So the formula you can recall, total defective times 1 the power of 6 divided by total calls. Okay, this is the 78228, 78,000. Let's see how much we have. Exactly the same value we have got, right? And then sigma value equal to n 1 minus sigma value divided by 1 the power of 6. 1.41, exactly the same value, 1.41, exactly the same value we got. I hope you find this video useful and informative about process capability using or for the binomial distribution. We did the binomial distribution. Why we did binomial distribution? Because we dealt with the discrete data, pass, fail, and all that. We dealt with that. And very quick, fast forward, how to do. All you have to do is you have to go to, if you want control chart, just go here, the control chart, and attribute chart, and P chart, and you can give OK, and call unanswered total calls. You can give OK. Like this, what you got it. If you want the process capability, controlled quality tools, and then binomial, and then we have keyed in on total calls, call unanswered total calls, and this you can give OK. So if you want everything together, you can find it using the layout. Lots of graphs we have done it. What I will, this is one, and let's say P chart. This is only P chart. This is no, this P chart is for second example. I'll keep it here. And okay, this is the right one. So this is the one, same one, unanswered call. The same thing I will also take it for the defective also as well. Okay, and this is only for okay. We have, because we have taken two different things. There are two different worksheet. That's the reason it is showing. But nevertheless, so this is very easy to understand the process capability using Minitab. And I hope you find this video very useful, very informative. Please do like.